Hey, what's up, guys? Very good morning, good afternoon, good evening. Okay, to all of you. And I hope all of you are very safe and healthy. Okay, and this is in continuation to my AWS video series, the introduction to all major AWS services. Okay, today we will discuss one another AWS service that is AWS SQS queue, simple queue service. Okay, so this SQS simple queue service is also another very important AWS service that also plays a very significant role in application architecture and the enterprise application development. Okay, so basically it's a message queuing service. Okay, it helps the two different services. Okay, there are two different microservice. Let us in terms of a shopping portal. Let us imagine like there are two different API projects. Okay, that is deployed on two different server. Like first is the order collection API service, and second one is the order processing API service, and there is one another that logistic API service. Okay, payment API services. Okay, and all these four services are deployed on different EC2 machines. Okay, in order to for the application decoupling. Okay, in the with the context of decoupled architecture, we have deployed all these microservices on different EC2 machines. Okay, and so what SQS service SQS queue helps SQS queue helps to communicate all these services. Okay, with one another. Like let's assume this way. Like if a customer, a user comes on a shopping portal and he puts he commits a purchase. Okay, he buys some product. Okay, then his request reaches to the order collection service. Okay, and then subsequently it should be notified to all others following services. Like once order collection is completed, then it should be the one notification of the message. Okay, should be passed to the order processing service. Okay, once order processing is completed, then it should be passed to the uh, logistic service. Okay, and subsequently all the connected services should process the data. Okay, so in that case, what SQS queue helps, like SQS queue works like a queue. Okay, where a service. Okay, the originating service, which is the origin of the event, which uh, which produces the message. Okay, which produces the event. Okay, that can push the messages to the queues. Okay, and the consumer services, like the processing services, as in our case, like order processing service, logistics service. Okay, shipping and logistics service, or the payment service. These are the service which are the consumer services which are consuming the message. Okay, so uh, if let us assume there is no any queuing service in the application. Okay, and all these four services are deployed on different EC2 machines. Okay, how the communication will happen between all these microservices? Okay, because in that case there will be a simple API call that once order is collected at order collection API service, it will then call an API service from order processing service. Okay, within itself. Okay, and once order processing job is completed, then order processing microservice will call another API in within itself. That is the logistic service. Okay, so it will be subsequent API calls. Okay, and in real-time application, real-time scenario, if there are a huge number of events are happening, like uh, millions of sales are happening. Okay, then it will be difficult for the services to react real time. Okay, because respond or process all those events simultaneously, and it may be there may be scenarios like a particular microservice won't be able to process all those events at the rapid speed. Okay, and their rates for processing the messages, or the rates for processing the orders or the events. Okay, that may vary. Okay, that may not be efficient in order to process all the requests. Okay, so in that case, the AWS SQS queues or any queuing service plays a very significant role. Okay, what happens when in this example, in the shopping or e-commerce web portal, all the purchase events, okay, first stores the all the events in all the sales events or the purchase event in terms of message object in the queue itself. Okay, and it is all those events are waiting within the queue until any corresponding processor service, okay, or the consumer service doesn't pick the message from the queue and process that message. Okay, so there the chances of losing the message are just gone here. Okay, we will not lose the messages, we will not lose the events. Okay, because until any connected consumer service has not picked the message from the queue and has not processed the message, till that time all those message objects are residing in the queue itself. Okay, and we can also define the retention time, like how long the object or the event, okay, the input event will in terms of message object will be retained in the queue itself. Okay, so that is the functionality of the queue. Okay, it sits between the producer, okay, a service which is producing the event or the message payload, okay, and a service which is processing the message from the pulling the message from the queue and processing it. Okay, so it is, you can consider it's a holding queue, okay, which holds the messages until some service comes and picks the message and process it. Okay, and you can also consider, like when you are going to book a movie ticket. Okay, you follow the queue. Okay, and that is also being served one first in first out basis. Okay, and multiple queues are there. Okay, and that is a queue where multiple people are waiting for their turn. Okay, and the booking person on the counter is booking the tickets one by one. Okay, so once the booking counter, the person sitting at the booking counter, you can consider as the processor service or the message processor service. Okay, and the queue where the people are standing, that you can consider as a queue. Okay, and all other people are coming and just being queued in the queue itself for their turn. Okay, so the queue is this SQS queue you can consider the similar like a queue in the application architecture. Okay, so it is the fully scalable service. Okay, from AWS, and it's completely serverless. Okay, it doesn't require any EC2 instance or virtual machines to be to configure the queue. Okay, it is because it is serverless. AWS provides its own console where you can create the queue. Okay, you can configure all of its properties. Okay, and you can you can make the use of this SQS queue in your applications, in your API project. Okay, and the projects which are deployed on different environments. Okay, and you can connect the SQS queue from serverless applications also, like AWS Lambda also can connect the SQS queue to pull the messages and process. And even if you have written your custom API project in .NET Core or Python or any other preferred language, supported language, okay, those API services also can connect to SQS queue and push the events, okay, and pull the message objects itself. Okay, so that was it about the SQS queue. Okay, and let us understand the more in depth and detail of this queue itself. Okay, so you can consider see this image. Okay, like, so we have a web API service that is producing some message. Okay, like in our case, in terms of e-commerce websites, if the people are doing some purchase, okay, it is creating a message object that is the JSON payload. Okay, that contains all the purchase details, like the name of the product price, okay, and the quantities and the product attributes itself. Whatever the purchase is happening, it encapsulates all the purchase detail in the message, and this service is pushing the sales message into the SQS queue. Okay, that process is called enqueuing the queue, pushing message to the queue. This is the producer service. Okay, and this producer service, or you can consider it as a order collection service. Okay, as we discussed in the previously, order collection web API service that is deployed on a particular on a separate EC2 machine that is collecting the orders from the front end web portal, and that is pushing the sales JSON, okay, or the purchase JSON into the SQS queue itself. And there's another service that is processing the message that pulls all those messages from the SQS queue one by one. Okay, and it is processing the objects, okay, or the purchase request, and after that it is deleting the message from the queue itself. That process is called dequeuing the queue. Okay, so we can see in this picture here that SQS queue stands between the two different services. Okay, and these two different services are hosted on altogether two different virtual machines. Okay, and even those two different virtual machines can be on two different region itself. Okay, let's assume if you have hosted this order collection API service in one availability zone, okay, and this order processing web service or the API service in different availability zones, okay, then this SQS queue also, SQS queue is a serverless application, serverless service that is available on AWS console itself, okay, and it acts as an mediator or the middleware between the two different services. Okay, so the model is completely quite simple. It's producer and message processor or consumer model. Okay, the one service is producing the message, and another service is pulling the message from the queue and processing it. Okay, that's the simplest architecture. Even there will be different case also where a single service or one service which is producing the message and pushing the messages into the queue. Okay, and other side there will be multiple services. Okay, that and all those services can pull the messages from the queue and process the messages. Okay, so that is also in the application where it is configured like load balancing thing, where messages from a same queue are being pulled by multiple services, multiple processing services. Okay, and all the messages being processed. Okay, in that case, the one message will be received by only one consumer itself. Okay, that message will not be available to another consumer. And here is one important thing, like when a service, the processing service, in our case, like order processing service, if let us assume there are 4 order processing service, like here, like service A, service B, service C, and service D, and all those services are connected to the queue, and their responsibility are to pull the message from whatever new messages are coming in the queue. They pull the message, okay, and process it, and they will delete the message. Okay, so here there is a term visibility timeout. Okay, that is by default it's 30 seconds. Okay, let us say in the queue it's currently 4 messages are residing, 4 message objects are residing here, and service A picks one message from the queue. Okay, and then it has 30 seconds. Okay, within 30 seconds it has to process the message. Okay, and for that 30 seconds, when that particular message is pulled by the service A, that message object will be locked. Okay, it means that no other service will have access to that particular message object. Okay, and once that message is processed, then that message will be deleted from the queue. And if the message if the service which has picked the message from the queue is not able to process the message within the 30 seconds, okay, then the message will be returned back to the queue. Okay, and the lock will be released so that other service can pick the same message to process. Okay, so that is called the visibility timeout. That is default 30 seconds. Okay, but we can configure that as per the requirement. Okay, so that was another important point that I needed to explain here. Next important things about the SQS queues are why we need SQS queue. Okay, As in short, we understand that it works as a middleware between the two different services or multiple services. Okay, and all the services can connect to one another or each other via SQS queue for the message transmission, message sharing. Okay, but controlling pressure on backend data processing service. Okay, so as we discussed, like there's a front end application like e-commerce portal. Okay, and let us assume in the peak time there is huge traffic on the portal. Okay, a much bigger sales are happening. Okay, in case of millions of sales happening per hour. Okay, in that case, if there are backend services, that is flat API services, okay, that is processing those sales events. Okay, and if the services are not being able to process the events for any reason, like they are uh, uh, limitations of some infrastructure there or some other outage, the storage or the some outage there in the background. In that case, and it is not possible for the API, the flat API service to process all the messages in so rapid speed. So in that case, the queues plays a very important role. Okay, so the initially all the orders are being queued within the SQS queue itself. Okay, and the backend service which is processing the orders, okay, they can pick the orders one by one from the queue as at its own pace. Okay, and then they can process the sales or purchase event. Okay, so we have the flexibility that we can define the rate of processing for the services at our own requirement itself. Okay, it doesn't have the pressure on the services that a particular service has to process all this much of requests in this particular span of time. Okay, so that is the one requirement, like controlling the pressure on the backend service or the data processing service, and that is being initiated from the front end applications or the public facing interface. Okay, async operation, fire and forget. Producers should not worry about the client processing. Okay, so let us take the example of this again, e-commerce applications, like multiple sales are happening. Okay, the user is coming on the portal, they are committing they are selecting their products, and they are submitting their sales. Okay, committing the sales. Okay, making the payment, and the order is done. Okay, so the front end application is continuously submitting the orders in the queue. Okay, and they don't have to worry about that what happened, like the backend service will process the event asynchronously, and the responses will be returned. Okay, so it's a fire and forget and a synchronous method. Okay, the front end, the one layer, the service, the producer service is not don't have to worry about the processing service. Okay, that what will happen. Okay, that is the responsibility of the processing service. The processing service or the order processing service in our case can pick the message, pick the sales event. Okay, process it, and whatever the conclusion he has to make. Okay, the final transactions it has to commit, it will do on its own pace. Okay, so that is the requirement, one of the requirement where we can make the best use of SQS queue, that is asynchronous operation, and that is also in the fire and forget manner. Sorry. Next is eventually guaranteed processing, like it is very trustable, like all the orders will be queued to the queue. Okay, and it is guaranteed that all the messages will be delivered to the respective order processing services or the backend services which is processing the service. Okay, so not the real time, but it is in asynchronous mode. Okay, in asynchronously, the message will be delivered to the connected backend service at least once. Okay, eventually. So that is the require another use case. Application decoupling, like yeah, the same thing we discussed, like in e-commerce applications, if there are multiple microservices are there, order collection API service, sales API service, payment API service, okay, logistic shipping and logistic API service, all these services are decoupled. Okay, they don't have the tight binding or tight dependency on one another. Okay, they are decoupled and hosted on different environment itself. Okay, but the communications, they are coupled, they are communicated, they are connected with one another with SQS queue. Okay, so it plays a very significant role in application layer decoupling. Distributed architecture, the SQS queue plays a very important role. Okay, so with this image we can understand better, like when there is no SQS queue and two different services are connected, what will happen that one API service will call the another API service in between, and if that is going to fail, then it has to some we have to write some custom logic, okay, to retry that. Even after making two or three retry, if it's failed, then message is being lost. Okay, and that particular event on transaction is completely lost. Okay, that is that we may face when we are not using any queue or any middleware in between, like queuing service. So this is happening without using SQS, but between two different API service. If we are using SQS queue in between, then it works like a middleware in between that holds the messages what is being pushed from the service order collection service to the order processing service. Okay, and order processing service at its own flexibility can pick the events or the messages from the queue and can process one by one as per its own time, own flexibility. Okay, so that is the benefit of SQS queue itself. Okay, yeah. Further, there are two types of SQS queue on AWS. First is standard queue, and second one is FIFO queue. A standard queue, like in a standard queue, there is no order or no respective order of the messages. Okay, like if there are multiple messages in the queue stored, okay, it's not necessary that the it will give the messages to the polling service, okay, or the service which is processing these objects of the message on sequential basis. Okay, it even the service which is processing can pick the can when it will poll the queue, it can get the object 5, object 4, object 3 to process. Okay, it's not that it will get only first item first, then second, then third, fourth. Okay, so that is the standard queue. Okay, it doesn't maintain the any specific order, but yes, on its own intelligence, it also maintains a best possible ordering of the messages. Okay, that will be delivered to the processing service. Okay, and all the messages are will be delivered at least once to the service which is processing the messages itself. It's unlimited throughput. Any number of messages or the transactions can happen on this standard queue itself. And the second one is the FIFO queue, the first in first out ordering, where all the objects are stored in a sequential manner. Okay, and which the object which has entered the queue first will be returned to the processing service in the same order. Okay, so that is first in first ordering of the objects exactly once delivered. Okay, in the standard queue, our object is if our object is being pulled by the service. Okay, if it could not be processed, okay, it can there are retries can happen, and at least once the product will be delivered. Okay, the message payload will be delivered to the service. But in FIFO, there is not retries. It will be exactly only once this payload will be delivered to the service itself. Okay, and the service has to process the message and dequeue the message from the queue itself. It has the limitations of 300 transactions per second. Okay, max transactions, and the service can pull the messages in the batch manner also, like 5 messages in one pool, 10 messages in one pool. Okay, so the batching we can do in itself. So with the batching, it's the limit is 3,000 transactions in the batching itself, in the batched manner. FIFO queue is 25% more expensive than a standard queue. Okay, so we can select the type of queue as per the requirement. Okay, if it's not necessary for the message to be processed in the sequential manner, then we can opt for the standard queue. But if it is extreme necessary for the messages or the events to be processed in sequential manner, okay, then we need to select the FIFO queue itself. Okay, so that is the two type of queues in the AWS. Okay, so there's a fan out feature, like we have notification service in the real time. Okay, when any event happens, okay, we can connect the SNS service, that is simple notification service on AWS, and simple notification service once received the event, okay, it can fan out the event to multiple queues, like in the same way that if any order happened, okay, the purchase happened on the e-commerce portal, through the SNS service, we can notify the event or the input message to multiple queues, like analytics detect queues, okay, dashboard service queue, and the fraud detection queue itself. Okay, all these three different queues are there, and respectively, their different services are connected to these queues to for the data analytics work. Okay, dashboard preparing the sales dashboard and detecting any fraud on the portal. Okay, so all those services can be connected. So this is working with the SNS simple notification service also. If services are host services which are processing the messages, okay, from the queue, can be server based or can be serverless itself. Okay, if our services or the API project, okay, or the microservice is hosted on EC2 instance or the virtual machine, that is server based. Okay, and if we are not using any EC2 instance, okay, but we are processing the messages with the help of Lambda function. Okay, so that is serverless. Okay, so Lambda function can also connect to SQS queue, can pull the messages, okay, and can process that message itself. Okay, so it also works very well with the conjunction of serverless AWS services itself. Okay, and in case of we can use the SQS queue for the job offering also. Like in there's a requirement, like every night there should be some database backup should be happen every 12 night 12 night itself. Okay, so with the help of CloudWatch, we can generate an event and to SQS queue on the timely manner that we have to generate the backup of the database, our respective database, and save the database backup into a particular S3 storage. Okay, so we can have the services installed on EC2 instance. Okay, and once the CloudWatch event is being generated and pushed to the SQS queue, the respective services, the backup services from the EC2 instance can pull that event from the job from the queue and start taking the backup of the database. Okay, and once the database backup is created, they can store the backup in the S3 itself or somewhere else. So that is a kind of job offering. Okay, that where also it is a good scenario where the SQS queues plays a very, very important role. Okay. So next, multiple threads, processes, services can pull a queue at once. Okay, as we discussed in the previous slides also, like a single queue can be connected to the multiple processing service. Okay, multiple services which are pulling the messages from queues and processing the data. Okay, so it's one queue can be connected to the multiple threads, multiple processing service. Even a single thread can be connected to a process queue. So a queue can be connected to a single processing service and multiple processing service also. Okay, both the scenarios can, as per the requirement, both the scenarios can be configured. Long polling feature is also supported with SQS. Okay, what is long polling? So it's a poll-based service, right? The API service, which is responsible for processing the message, need to poll the queue every 5 minutes or certain duration. Like, do you have any message? Do you have any message? Do you have a new message? Okay. Instead, it is long polling is supported. Okay, the service is once connected to the queue. Okay, or instead it is asking for every 5 minutes or every a certain duration, like for any new messages. Okay, it is configured in long queue, long polling. And once a new message object is created in the or entered into the queue, it will be automatically returned to the connected processing service. Okay, so that feature is called the long polling. Okay, so that we can configure with SQS queue itself. Cross account process polling or the message is supported. Okay, like as we discussed, like if yeah, so order collection. Let's re- reiterate our example of e-commerce application where order collection API services we have hosted in one EC2 instance, that is in a single AWS account. But order processing or the logistic and shipping and logistic API service that is hosted in different EC2 instance in different AWS account. Okay, both account are different. Okay, but the account can connect to SQS queue. So that is the SQS queue in either of AWS account. So that is it about the cross account process polling of the messages is also supported in with SQS queue itself. Maximum message payload size should not exceed 256. So maximum payload size is 256 KB. Okay. So any message payload or the JSON payload of the data that is to be processed, that should not exceed 256 KB in size. DLQ, date letter queue, can also be configured. Like as we discussed, like the producer service is pushing the message to the queue, and the consumer service is pulling the message from the queue and processing the messages and deleting the messages. In a certain scenario, in case the consumer service is not able to process the message after multiple retries, okay, then this kind of configuration can be done. Like it will push that particular message in the date letter queue. Okay, so date letter queue is a different kind of queue that can be configured. Okay, and where all those failed messages which could not be processed in the standard fashion, okay, will be stored there, and later with the help of some different Lambda service or API service, we can pull those messages also, and can later analyze and reprocess those messages, and can analyze that what was happened, what was the reason that it could not be processed. Okay, so that is also can be configurable with the help of date letter queue with SQS. Okay, so that was all about SQS queue. Okay, I hope you like this video. Okay, and guys, if you find this video very informative, okay, please like the video and subscribe to our channel. Okay, it really motivates us to create more videos, more such interesting videos for the community. Okay, and you all of you will be automatically notified whenever we are uploading any this kind of interesting content to the channel. Okay, thank you very much for all joining this video, watching this video. Okay, and stay happy, stay healthy, stay connected. Thank you very much.